Quadratic formula. We are going to be working with the quadratic formula in this lesson. There is a video also attached to this, a YouTube video about memorizing the quadratic formula song to the tune of Pop Goes the Weasel. Please watch it. If you recite or sing the song to me before the test, it will be bonus points on the test. So quadratic formula is what we can use to help solve some quadratic equations that are not set up as conveniently as that can be factored. So this is the ones that we're going to have irrational solutions and hard to work with through solutions. And so we are going to, first step is always get all the terms on the same side. So we're going to add 11x to both sides. It cannot combine with the other terms here. There's no other, just x to the first exponents. So they're going to be listed separately. Next thing we're going to do is we're going to identify the a, b, and c terms. And that's the a is what's in front of your x squared. So in this case, a is 10. B is what's in front of your x term. So in this case, 11. C is the constant term, in this case, negative 13. After we have that identified, we are going to go into the portion under the square root of this quadratic formula. And that is called discriminant. And that is the portion that is the b squared minus 4ac. And so we're going to do 10 squared minus 4, actually not 10 squared, 11 squared minus 4 times 10 times a negative 13. That comes out to 641. Now, this is going to be going into the quadratic formula. And so this is going to go inside that square root in the quadratic formula. And that is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So we're going to take this number, we're going to put it inside the square root. So we're first going to simplify and figure out what pieces can come out. And as you start looking through it and look and see what we're dividing in, and you go to the first prime number, so we try, it's not even, so we know we can't divide by 2. We try 3, 7, 11, 13, or 3, 5, 7, 11, 13, 17, and 19, and none of those divide in, then we're just going to put this number under the square root. But if one of those do, which we'll look at a problem where that happens in the next problem. And so right now, that's the only thing that's going to be under that square root. So we're going to replace all our pieces in our quadratic formula with what goes in the spot. So negative b is another way of saying that is opposite b. So b is a positive 11, so we're going to put negative 11. Plus or minus, what this means is there's two actual answers here. One time when we're going to add the square root, and the other time we're going to subtract it. And 641 was what the number was for the square root, divided by 2 times a, which is 10. So x equals a negative 11 plus or minus the square root of 641 over 20. Because there is nothing that can come out of the square root, there's no further way for me to simplify this. The assignment may ask you to go to the decimal. If it does, you type that in the calculator as negative 11 plus the square root of 641 divided by 20 and find that decimal. And you do the same thing with negative 11 minus the square root of 641 divided by 20. And once you have those two decimals, you can put it if it asks for decimal. If it asks for exact values, be separated by a comma. Those are the two things you'll write. So on this next question, we have 5r squared minus 3 equals 12r. So step 1 is get the 12r moved over. And that leaves us with 5r squared minus 3 is equal to, minus 12r minus 3 is equal to 0. Next, we're going to identify A, B, and C. A is our number in front of our square term. B is equal to the number times our variable without a power. And C is our constant. And if you notice, I'm taking that sign with it as I'm going. So the next thing we're going to do is we're going to find the discriminant. And so b squared minus 4ac. So b squared would be that negative 12. Be careful on this that you put that negative 12 in parentheses. And you're going to square it minus 4 times 5 times a negative 3. And when we do that calculation, we come up with a positive 204. So because this is something that I know we can simplify down, it's even, that's just I know we can simplify it down. We're going to look and see what will divide in evenly. And so if I divide by 2, that leaves us 102. Divide by 2 leaves us 51. That's divisible by 3, which leaves us 17. So I have a set of 2's that will come out of that square root. So I need to take this number here, the 204, is our discriminant. We are going to use that number to find out what it would be to simplify that square root. So we brought out a set of 2's. The 3 and the 17 get left behind under the square root. And so that means that this all simplifies down to 2 times the square root of 51. That's what we're going to replace that square root with in the quadratic formula. And so let's go over and work with that. As the quadratic formula in this case is going to be r equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so r equals opposite b. So if it's negative 12, opposite of negative is positive, plus or minus. We found out that simplified radical ended up being 2 times the square root of 51 divided by 2 times a, which in this case was 5. So we have r equals 12 plus or minus 2 on the square root of 51 divided by 10. Now, look at the numbers in front of the square root, the number in the front, and the denominator. If all of them are divisible by the same number, you can simplify that. So these are all divisible by 2, so I'm going to divide each of those numbers by 2. And so that's going to leave us with r is equal to 6 plus or minus 1 times the square root of 51, which is more simply written as just the square root of 51, divided by 5. That is one way to write it. These are the other ones. So we can do it as a plus or minus. Or you can separate it into 2 fractions like I have them here. Or if we wanted to write it out into 2 separate whole fractions together with the plus or minus, you can do the bottom option. Now, the last problem we're going to work with, we're going to go ahead and move that 5n over. And we're left with 6n squared plus 5n minus 11 is equal to 0. So we identify our ABC. So A is 6. B is 5. and C is negative 11. Then we're going to go into our discriminant. B squared minus 4AC. So 5 squared minus 4 times 6 times a negative 11. And so when we find that number, it turns out to be 289. So one of the things that I didn't talk about the last one because it wasn't a perfect square, and so I always forget to check it whenever it doesn't turn out to be one. If you take the square root of 289, it's equal to 17. So you don't have to use the upside down division to simplify it. It already is 17. Your upside down division would reveal the same thing. There's no reason going through that. So now let's go ahead and go into our quadratic formula. This time it's going to be n equals negative b plus or minus the square root of b squared minus 4ac over 2a. And so n equals opposite b, so b is 5, so opposite b is negative 5, plus or minus 17 over 2 times a, which is 6. So simplifying that a little bit farther before we go on to the next step, we're going to combine our denominator, and that's going to be 12. Now we're going to figure out what these two fractions would actually be. And so negative 5 plus 17 divided by 12 is one option. The other one is negative 5 minus 17 divided by 12. So negative 5 plus 17 divided by 12 gives us 12 divided by 12, which is 1. Negative 5 minus 17 divided by 12 is going to give us a negative 22 divided by 12, which reduces to a negative 11 twelfths, or negative 11 sixths. So our answer for this problem is negative 11 sixths, comma, 1.